Hey everyone, welcome back to another short video from Fluree. I'm here with Brian. Brian, hello.
Hello, Kevin. Glad to be back.
Today's discussion, we're going to talk about SHACL Validation language that's largely pushed by the W3C. And Brian, I don't know too much about SHACL, so I'm going to hand it off to you. What is SHACL?
Yeah, SHACL does a few things. So it's most commonly used as a data quality tool, but it does do more than that. And I'm sure we can dive into that a bit more. It also has this interesting capability that allows you to auto-generate editing forms for end users that can also be described using SHACL. So that's kind of a cool additional capability that I think a lot of people who've even used it aren't aware of. And then at Fluree, we actually use it in a slightly different way than its main purpose, tightly related, but not how everyone ends up using it.
Okay, I want to get into that, but first, so when you say data quality, that can mean a lot of different things. And in my understanding, it's really validating data against some rules to enforce some sort of shape of the data. Is that sort of accurate to state?
It's exactly accurate. And, you know, there's different forms of validating data rules, everything from very basic schemas. Of course, you have things that have no schemas, right? There's no validation. Then you have things like relational databases, which define tables and columns and then data types for those columns. When we get into SHACL, we get into something not only appropriate for graphs, but the capability that it has is just well beyond that. So you can do very sophisticated things.
And who would implement SHACL? Who's seeking SHACL out? Is it perhaps the data governance office? But we know it comes from the W3C, so perhaps it's someone within a knowledge graph team at an enterprise?
Yeah, it could definitely either of those. So someone who's already familiar with knowledge graphs and the standards likely has heard of SHACL and sees value in SHACL. There's, you know, a degree of debate between OWL, which is another way of not only modeling data shapes, but also doing a lot of ontology related things. And SHACL, and there's some overlap between the two. So, you know, there's some people who have an opinion, you know, on which one they like, but there are some strengths, you know, to each. So definitely someone in the knowledge graph space that's familiar with these might be looking at SHACL. Data governance, absolutely. You know, any sort of data sort of cleansing analysis where you're trying to pull data together in data engineering, data science, they would be a good candidate to kind of understand data that they're using doesn't meet some minimum criteria that they're concerned about. And then, as I'm sure we'll talk about, we actually use it to validate transactions because we focus on this space not only as an analytic tool, but as an operational data store. So we end up treating it kind of like a SQL schema does treat it, a schema that is for a relational database, where we'll actually reject attempts to update data if they don't meet a certain criteria. But in a lot of cases, it's more being used not as a system of record validator, but more as something else created the data, not me, but now I want to see if it actually meets some sort of minimum criteria.
And like you stated before, you sort of teased that this might be implemented in an end form by a user. And so what you're essentially saying is we can set up SHACL rules and those forms legitimately have to constrain the intake of the data to adhere to those rules?
Yeah, so you think about something like a web form, right? So I've defined using SHACL, and you can define this using OWL. You can define, you know, a lot of these things in several ways, but those would be two very popular ways. I've defined a set of fields for a class of data, maybe employee data. You know, maybe I make widgets, right? So it's what a widget looks like. It has a height, it has a weight, it has a width, it has whatever. So these are all the properties that would exist on that class of data. In SHACL, you can sort of annotate the not only from a schema enforcement sort of standpoint, what's going to be valid in each of those? Is this thing kind of like a pick list or an enum value sort of thing, like picking states, right? So all of those things you would normally think about. It also allows you to annotate those properties and be able to describe an ordering for something like a form field and even grouping. So, address might be a good example where you obviously want the street address, then the city, state, zip or postal code, maybe in that order. But perhaps you also want those things arranged in a grouping together so that they look like one entity. And it even includes some metadata to say, hey, group these things together into a group called address. And then within that group, display them in this order and display other things. So it's a great way of, or one way of describing via data the way a form should be rendered for an end user to actually input or do additional things.
And that sounds like it would save a lot of time and potential data engineering effort for an organization that might have multiple systems of records that are taking in information through lots of different forms. I'm thinking healthcare, for example, patient intake forms across different hospitals, that sort of thing.
And we actually have a client with this use case, but yeah, exactly. Where, and this is more on the data governance side, right? So somebody is saying, look, for a patient intake, we absolutely need these things. They have to look like this. This needs to match this regular expression. This needs to be a number between this range, but also this is the way I want the form painted on a screen. And all that's described with data. So a web page renders it. And of course, the web page can look at that and paint it in the right way. Some proprietary app might render it. It might have a different way of representing a form, but it has all the metadata it needs to figure out how to represent that form dynamically. And then, the data governance person, maybe there's a new field, maybe there's a new regulation or a change for 2024 or 2025. They can actually then, at a metadata level, describe those changes. And then anything that's collecting that data, rendering forms for end users downstream can leverage that metadata.
That's super interesting. Before we get into how Fluree implements SHACL and some of the history behind the product there, I just want to ask, do you see any downsides of SHACL? Have you run into any instances where SHACL might not be the best choice?
Well, I think where SHACL excels is it is a far more powerful and data-driven way of describing what sort of data is valid and what isn't valid. So it gives a lot of capability. I touched on even just a few in that last example I gave, but it even gives the ability to peer through properties, sort of like child properties and child classes and shapes, and say, certain things, even in connected data, have to be valid for this thing to be valid. So that goes well beyond anything you'd think of with like a typical schema. And you don't have to use it, right? It's just there if you want it and you want to enforce it. Where'd you start out with that question?
Well, so I asked about any sort of negative consequence, and then you just launched into why
the positive.
It's so great.
Well, so anyway, so that's the big positive, right? If you think about schemas, then this is schemas plus, right?
Okay.
So validating data. So the negative side would come, I think, more from the knowledge graph community, and which you seem surprised by.
I am, yeah.
That is because the knowledge graph community, at least a large chunk of them, are very committed to OWL and are very committed to, what they would say is an open world concept. An open world concept makes it actually really hard to validate data because it kind of says I never can be sure I have the complete information about a person,
right,
or a thing or a class, like about you. I may have some information about you, but I can't say that the information I have about you is complete. There can be other things out there that also have information about you. And then that makes it difficult. Like, how do I enforce a cardinality constraint, for example, and say, well, there have to be two of these things? If I'm coming at it from a philosophy where I have one thing, but there might be something else out there that has one other, I don't know what else is out there. So that's kind of the challenges with the open world concept, is that you can never assume that you know everything. So then how can you validate things if you don't know anything? So it's pretty minimal what you can validate. And there are some things you can validate with OWL, but it's pretty minimal what you can validate with OWL. SHACL really addresses that concern.
Of course.
But to address that concern, you have to move to a closed world mindset. So that would be the big contention. And I brought up kind of, some people like SHACL, some people don't. And that would tend to be someone who's very committed to kind of this open world idea of thinking about data. SHACL breaks that assumption, but SHACL can be incredibly practical, especially in an enterprise data setting, where oftentimes they are thinking closed world, or that is a priority for them to do things. And OWL would not be able to allow them to describe some of those constraints they really feel are important for their business and business processes. But
yeah, that makes a lot of sense. I could see SHACL being used more for certain use cases, such as compliance, where there is no gray area or room for gray area. And I could see OWL being used, and of course I'm speaking generally here, for perhaps research and development, where there is maybe a little bit more room for new concepts and ideas in the data environment.
Yeah, and I would say generally, why does someone want to use OWL? And I think OWL has a lot of great benefits, which SHACL has zero capability of doing. So people don't usually turn to OWL for data validation.
Right.
Now, it can inform some things, and there is some things you can do, but they're usually using it to, model a domain of knowledge and to infer data automatically with rules. They're kind of using it for different reasons. It just so happens that there is a little bit of sort of data shape describing capability in OWL. That is SHACL's core focus. And so they have a tiny bit of overlap, but really they're kind of two separate use cases.
Are there scenarios, and I want to get to Fluree, but I'm just curious now, are there scenarios in which folks would use both OWL and SHACL?
Sure.
Okay.
Yeah, I would use OWL for doing data inferencing, and then I would use SHACL for data validation, especially if I assume that I am only concerned about the data I have. I'm not concerned about connecting data to other parties where I have no idea what they have, and I can't control what they have and do. All the data I care about is my own. Therefore, I can take a very strict approach to how to validate that. But I still want to leverage some of the knowledge modeling and inferencing capability that OWL does, which SHACL doesn't even touch.
That makes a lot of sense. Okay, so at Fluree, we've just released V3.
Yeah.
Let's rewind to V2.
Okay.
I don't believe we had SHACL.
No.
We had something called smart functions. And a lot of the folks that have been following us for a while know smart functions by heart. Smart functions essentially perform the same activity that SHACL performed, as well as the data-centric security, the identity and access management, who can update what, under what circumstances, or who could read what data and under what circumstances. For Fluree V3, it seems as if we've broken those two out into SHACL and policies. Is that accurate? And what sort of informed that decision?
Yeah, it's accurate. I mean, I can't say that that's going to be the end state for sure, but I think it probably will be. But that is definitely the way it is now. So we used what we call smart functions, which allows you to create basically custom code or logic to do all kinds of things. But the big things were both sort of dynamically generating new properties and transactions, or property values in particular. We used it for defining policy, who can see what data and under what conditions, who can transact what data and under what conditions. And Fluree's got some super capabilities around it that makes this very dynamic and still performant. And then this, ways of creating custom logic to constrain schema/shape, however you want to, describe it. There was some kind of basic things like data types. You didn't have to use a smart function to do that. We had some out-of-the-box ways of doing that. But anything more sophisticated than that, you would turn to smart functions to write your custom logic. What informed the choice? So for one, SHACL is gaining some speed. It's relatively new. And when we designed a lot of our original concepts, it just wasn't really on our radar. I can't say that it didn't fully exist when we started, but for sure it wasn't like on our radar in any way. So we already had this one capability. It made sense to use it for all of these different things. Now that we have a lot of experience and a lot of users of Fluree, we've had a chance to get, I'd say, more feedback on how they actually use those things and what they're trying to do. And I can pretty comfortably say that SHACL actually solves, I'm spitballing, but 99.9% of what anyone would want to do with data validation. It's a standard. There's resources out there. It's interoperable. Why not leverage it, right? And so the reason I threw that caveat is maybe it doesn't end up being the only way. Maybe we still have smart function capability, is because there is that other 1%, right? And so, one of the ways I could see us addressing that is like, okay, just describe it with SHACL for the things that SHACL does really well. But if you truly have very custom shape validation logic, you can still turn to custom programming if you need to.
Okay. That makes a lot of sense.
But right now you can't do that. And I think actually SHACL is more than capable for what, really any of our users that we've run across need in this category.
And then policies are just under a sort of separate mechanism now.
Yeah, so enforcing policy and permission is a bit of a different animal. One of the things that we have done, though, is evolved a little bit of how we look at policy. And we have replicated or used a similar pattern that SHACL uses to describe those policies. And the specific pattern is with SHACL and now our policies, is that you define a criteria that determines whether or not your rules, some set of rules, SHACL rules, policy rules, applies to a given node in the graph or a given subject. We talked about Kevin, right? Being something that exists in the graph. It has a bunch of properties. So what applies to Kevin? And there's multiple ways of targeting where rules should apply to different things. One is you could say it just applies to everything of a certain class, people or employees, right? And then every employee is going to get policy validated or SHACL validated based on that. So the targeting mechanism is quite similar. So what we're trying to do is, the nice thing about smart functions is that it was one way of doing things, but you applied it sort of in different contexts. Now we've broken that a little bit, but we still want to retain as much of that consistency as possible. And the consistency that we've settled in on is the pattern. The pattern of how you sort of determine whether or not something should be under a policy is the same pattern you would apply to determine whether or not something should be validated by SHACL.
That makes a lot of sense. Is there something that I asked or did not ask about SHACL that you think I should have?
Well, we started out talking, and I mentioned that we use SHACL in a little bit different way than it's often used.
Yeah, let's talk about that.
And that's probably a little misleading. It's the same way, but we actually use it as a mechanism for validating transactions.
That's right.
And most people who have used SHACL today have used it because they're validating data that already exists. They cannot change the source data. It came from they could create a copy and then change their copy, right? But the source data is the source data. It's what's in Salesforce or what's in SAP or what's in whatever, right? SAP is controlling that. Something is controlling that. And they're working with RDF data or knowledge graph data downstream of that. So they can't enforce those constraints inside of SAP, right? SAP is doing its own thing. But one thing they want to know, perhaps before they're doing some sort of analysis or job or training a model, is like, is this data even good? Is it what I think it is? So you can describe those rules in SHACL, and what will output for you is a report that tells you the violations in the data. So it'll point you to the problems. And either you could create a copy and sort of fix the problems and write a script to do it, or you could say, oh, I thought this data was better. I'm not going to use it anymore. Look, you can do whatever you want with that exception report, but you'll get an exception report. It's going to tell you every place that the data was wrong. But it's really, a lot of people use it like that. They use it downstream. They don't really have control over the system of record.
And I think that's indicative of how folks are building knowledge graphs today, mostly, which is on top of existing legacy systems.
a lot. Yeah,
Right.
Yeah. Or specific use cases and analysts that are kind of dealing with this. But yeah, more times than not, these folks are dealing with
The
data downstream.
Right. The data is not born in the knowledge graph. It needs to sort of arrive into it. Yeah.
So we have a very strong focus on enabling developers to actually originate more data in the knowledge graph. And we think that has tremendous potential. And of course, we've talked about many aspects of that before. And then one of the things that we focus very heavily on now is doing that using JSON LD, only because we can't really make that happen until we make it easy enough for developers, to work with it. And I like to think of it as having, all of the niceness of a schemaless format that attracts developers, for better and for worse, to something like a MongoDB. But then being able to actually have this immense power that analytical capability, query capability, that MongoDB can't even touch, right? So but it's historically been hard for people to learn, right?
Sure.
To think about data differently. They're trained on relational databases or whatever. So we think JSON LD is a wonderful bridge for that. But now that we're getting more people to actually use this knowledge graph format as a system of record, it means that we want to use enforcement of data quality the same way other databases do that they're used to.
Right.
You set up a schema in a SQL database, and if you try and put a number where it expects a string, it's not going to let you do the transaction. And this is actually what SHACL's perfect for. So we actually have heard people trying to use SHACL kind of like this. The problem is it's in a separate process. It's doing some validation. It passes that validation, and then they go ahead and transact it into a knowledge graph. But the conditions might have changed between the current state of the knowledge graph and when they did that validation. Even if it was a millisecond apart, the data is constantly changing, so the validation is never quite current. And we are able to implement this rule enforcement right inside of the transaction queue. There can never, ever be any inconsistency, no race conditions, and it gives you just this far more powerful way of constraining data than you could ever even get from relational database or other mechanisms.
Yeah, I mean, this goes into the larger data reusability story. We always talk about future-proofing data for sharing and reuse. And governance is of course one aspect, and it's an aspect that seems like it takes up a lot of time and resources at organizations that need to grab information from a source system, bring it, perhaps into a knowledge graph, and then run some sort of analytics on it. We're doing that at the source, which I think is completely revolutionary, and hopefully we can get more end users and developers, into that format.
Yeah, and especially our ability to do policy constraints in real time in a scalable way, push queries to the edge, so these stateless query servers, all of these things are things that we and only we are doing. So it offers a lot of power. And, the other thing we talk about, especially when you can embed policy into the data tier, is your need for APIs, which is how people often share data, of course, starts to dramatically decrease and maybe even go away. Because that's what a lot of APIs do. They structure data in JSON usually, and they do policy enforcement. Well, if we're able to already get JSON out, JSON LD, you can actually use context, reshape your JSON, get your data out exactly as you want. The API is the query.
Right.
The policy enforcement is in the data. I don't need an API to enforce security or policy anymore. And then you start to think about SHACL as well as a tool like Swagger. So Swagger is a tool for you or others who don't know that people use to describe APIs. And then it can inform applications to know what sort of data to expect, what the shape is, right? And now, and it's become popular because it's kind of self-describing. It's data describing what an API looks like. The fields it expects coming in, the fields returning. Well, SHACL actually really solves that problem. So, the database is the API, especially when you have these capabilities. And you don't need Swagger, you have SHACL, right? So these are some other things that kind of offer additional potential.
Well, thanks, Brian. I really appreciate your time.
Yeah, thank you.
Thanks, everybody.
Hey, thanks so much for watching. Don't forget to like and subscribe for future updates from our channel. Visit us at Fluree PBC on YouTube and Twitter, on LinkedIn as Fluree, or on the web at flur.ee. See you next time.